Hello, biology humans. In this video, as you can see, we are going to talk about the greenhouse effect. Now, you just got done learning about the carbon cycle and investigating a couple models of the carbon cycle. And one of the takeaways, the main takeaway from those models, was that human activity is increasing the amount of carbon dioxide in the atmosphere. And that this increase is messing up the carbon cycle because the fossil fuels that are being burned, that carbon wasn't part of the system already, and so it's increasing the amount of carbon in all the reservoirs, but especially in the atmosphere. And so, why do we care about carbon dioxide in the atmosphere? Has to do with the greenhouse effect, right? And it has to do with energy coming into the Earth. If your body takes in more energy than you use, then you are going to gain weight. If your body takes in less energy than you use, then you will lose weight. For the Earth, if the Earth takes in more energy than it can release, then it is going to gain heat. The temperature is going to go up. If the Earth takes in less energy than it can release, then the Earth would cool down. Of course, we're talking about global warming. And so we're taking in too much energy, or rather, we can't lose it fast enough. So that means we got to talk about energy and heat for a second here. Energy comes and heat come in a lot of forms. The most basic way is radiation, like that comes from the sun, like light, which is part of our story today, or infrared waves, which is basically heat. In the image over here, you have the person with their hands to the side of the fire, right? And so heat is going to come off of the fire in all different directions in the form of radiation. This is just straight up warmth that is coming off of the fire, right? And so we are going to talk about infrared at some point here. Now, there's also something called conduction, which is when two objects touch. The heat will travel through an object or transfer from one object to another. And so in this particular image, the front of the poker is getting hot. And so the atoms here are very hot, and they're touching the atoms here, and they're touching the atoms here. And so the heat gets passed up the poker as through conduction. Convection is also part of our story, because convection is how heat moves around inside of a space. Hot air or hot water will rise thanks to the increased energy. And so the hot air rises, and then it starts to get carried by winds, and it starts to move around in the environment, and it carries that heat with it. And so in the image, you have the person who has their hands above the fire, which of course is a terrible idea, because not only are you getting the radiation that's coming straight up, but all of the hot air that is being created from the fire is going straight up, right? This is the hottest part of in this case, of the fire. And so there's three ways that the heat moves around: radiation, conduction, and convection. And they're all part of this story about the greenhouse effect. That should have been up there earlier. So here we have a greenhouse, right? It's called the greenhouse effect. How does a greenhouse work? Well, you have your solar radiation. The sun is shining on the greenhouse, and the light is going to go through the glass. Now, yes, and according to this little arrow, some of it's going to bounce off, but we don't care about that light. But some of the light is going to go through the glass, and that's the radiation part, right? And so it's going to be carrying energy with it, but not necessarily heat. The heat happens when it hits something, when it hits the ground, or it hits a plant, or it hits molecules in the air. The radiation will then warm up that object, the ground, the plant, or whatever it is, or the air, and then conduction will take over, and then convection. So the air will get warmer as the light turns into heat, and then the convection currents carry that heat around, and of course the glass keeps the air in. So the warm air stays inside, the heat stays inside, right? So you get the light in, and then it turns into heat, and the heat gets trapped. That's how a greenhouse works. The greenhouse effect is the same idea. You have the sun shining its radiation in, but instead of glass, we have the atmosphere. which is made out of certain gases. In particular, CO2, of course, is the number one, but methane is a big one as well. Water vapor, just water actually will do the job. Of course, that is a helpful thing. And then nitrous oxide is part of the nitrogen cycle. It's part of how bacteria and plants transfer nitrogen from one to another. So the atmosphere acts as the trap. The more of these gases that we have in the atmosphere, the thicker the glass would be, if you think of it in terms of the greenhouse, right? And so the energy comes in as light, as radiation, and it hits the ground, and it turns into heat. Now the Earth gets warm and radiates that heat back outwards towards space. But as the heat gets radiated outwards, some of it gets stuck inside of the now thicker atmosphere, if you think of it that way, right? It has more carbon dioxide, and so it's going to keep the heat in, right? And so thicker atmosphere leads to warmer Earth. Thicker atmosphere in terms of more carbon dioxide leads to a warmer Earth, and less carbon dioxide would lead to a colder Earth. And again, this is why we care about carbon dioxide being added into the atmosphere.